You have to know the carbon content or the nitrogen content or stuff like that. So people were able to take their anywhere from 35-pound to 200-pound piece of equipment, either on a roller, on a backpack. They're willing to do this because that material testing was so important, and that chemical composition, that full range, was so important. So they made the sacrifices to lug that equipment around and do that testing. Welcome to the Manufacturing Show. I'm your host, Chris Carolan, consultant at Metal Analysis Group. In this podcast series, Masters of PMI, my goal is to help you be successful with positive material identification and truly master your metal testing wherever you may be in the metal supply chain, all the way from scrap metal recycling and metal production at foundries and mills to metal parts fabrication and inspection. PMI testing plays an important role in making sure everyone knows which metal they are working with in order to avoid material mix-ups that can lead to unhappy customers, expensive recalls, and even catastrophic accidents like oil spills, plant explosions, and airplane crashes. And we don't like those things, right? So let's get to it. Today we're going to be talking about using mobile OES for positive material identification. I want to talk about this because OES is one of the primary technologies for PMI. It's been used for a long time, been used in labs and in the field, so it's really one of the basics that we need to cover to make sure we can master our PMI. So what is it? It's really got three main components. It starts with an electrical or laser-based source to excite atoms within a metallic sample so that they emit light, or optical emission lines, that are specific to each element. This can be done using an electrode or laser in order to heat and vaporize the material at the surface, which then emits the elemental characteristic emission lines. The second component is an optical system. The multiple optical emission lines from the vaporized sample are known as plasma. They pass into the spectrometer, and the spectrometer separates the incoming light into elemental specific wavelengths, and a corresponding detector measures the intensity of light for each wavelength. The intensity measured is proportional to the concentration of those elements in the sample. The third component is the computer. The computer uses the measured intensities, looks at the light data, and uses that data to determine the chemical composition or the chemistry of the material you're looking at. And often, like all of the PMI technologies, it's going to match it against a grade library and tell you not only the composition, but the grade that you're looking at, like stainless steel 316 or 304, or low alloy steel versus carbon steel, etc. Now, OES has been around for quite a while, and you've seen it in various formats like benchtop and mobile or portable units, whether in the lab or in the field. But for PMI, we want to focus on the mobile OES units, Spark OES portable mobile units. Because as PMI began to grow in need and understanding, it was understood that with XRF, which was the only one around to do this type of testing, you couldn't do carbon or other light elements very well with XRF. So that's where OES came into play. With OES, you can do carbon, nitrogen, sulfur, phosphorus. You can do those light elements. And even though you got to carry around a big bulky piece of equipment, sometimes in the field, like in pipelines or refineries, you have to know the carbon content or the nitrogen content or stuff like that. So people were able to take their, say, anywhere from 35-pound to 200-pound piece of equipment, either on a roller or on a backpack. They're willing to do this because that material testing was so important, and that chemical composition, that full range, was so important. So they made the sacrifices to lug that equipment around and do that testing. So it was a lot of work, but they get the job done. But recently, there have been advancements in laser technology that has allowed lasers to replace sparks in these applications. So basically the laser is replacing the spark as the source that is vaporizing the metal. And we'll go into more detail on this a little later. Just want to touch on some pros and cons of the technology of OES. Like I said, it provides the broadest range of elements of the three testing technologies or techniques, or XRF, OES, or LIBS. So it allows you to get a full chemistry. And with that full chemistry, you also get better accuracy and precision at very trace levels. So hundreds of ppm down to tens of ppm in some cases. Levels that handheld XRF and handheld LIBS you're never going to see them. So that's why people use OES. And with that full chemistry comes carbon, boron, sulfur, phosphorus, nitrogen, elements that can play a pivotal role in whether you're dealing with the right material, or it's going to hold up longer, it's going to behave like you expect it to. So those are elements you can't miss on. So that's why people use OES. Unfortunately, that's about it when it comes to benefits for OES. People have made many sacrifices in order to use this technology in the field, and it's not exactly point and shoot. You have to know what you're doing when you're testing with OES. It requires a lot of knowledge and a lot of training to be very successful in your testing and get good results. Sometimes you even have to know a little bit about the material. So you have to know the base material before you can test it, so it's matching it to the right calibrations. Like if you're trying to test aluminum and there's a steel program active, you're not going to get good values. So you have to know the base metal. And this also applies within those groups. So low alloy steel versus stainless steel or tool steel, etc. It can play a role in whether or not you're going to get good results. So you got to know that going in. There's also very high maintenance with these analyzers. They require a lot of cleaning, requires stuff like argon to make sure you're getting clean burns. So you're going through argon, you're cleaning your electrodes, you got to sharpen electrodes. There's lots of other parts you need to clean. So obviously you're burning a sample, so soot and dirt from those, basically that combustion activity, get on your analyzer and build up on the components if you're not good at maintaining the analyzer. And that's a big part of the cost. So to purchase, it's generally around $35,000 to $60,000 to purchase a new analyzer. That range is there because it matters how much the analyzer can do. So it's a little bit different from handheld in that you can get one with just a steel program or just an aluminum program or both. So that very greatly matters when it comes to price, the capabilities. If you need a lot of light elements, then you have to have a UV probe, for example. Sometimes you can get away without it. But if you need that probe, it's more money. And with that consistently high maintenance, it's a lot of upkeep. You're generally looking around $7,000 to $20,000 for repairs because it's not easy to transport. And when stuff goes wrong, it requires a visit from a manufacturer's service rep, usually. And this also leads to not much of a secondary market. So not only are you looking at parts, you're looking at personnel, you're looking at labor costs. So when these instruments stop working and they see a $20,000 cost for repair, people are more likely just to stop using them and look for another solution or look for a new unit that might not cost that much more. Some common mistakes people make when using OES, the most prevalent one is sample preparation. The idea here is you need a clean burn of the metal. So in order to do that, you have to have metal on metal contact so that electrode needs to be in contact. So you need a flat surface. It's got to be clear of corrosion or any other coatings. If you have any of that, it's going to give you a bad burn and you're not going to get all the light that you need to see and properly identify the alloy, because the light is the only source. And if you don't have strong enough light signals, you're not going to be able to tell which elements are in there. So with that, poor maintenance of the electrode can also cause bad burns. So if you're not cleaning it, you're not sharpening it, if you're misusing it, it can go bad. Not only the electrode, but not really cleaning all of the components. So there's mirrors and other parts within the system that need to be maintained regularly. The purity of the argon gas is very important. In most systems, if you're not using the ultra pure lab grade gas, usually 3 or 4 nines, maybe 2 nines sometimes, you're not going to get that flushed environment that you need to get you efficient burns that are giving you the most amount of light. And the last mistake I'll talk about is not allowing the analyzer to adjust to either its current environment or the new program it's using. These analyzers are very susceptible to environmental changes like temperature or humidity. So if you're moving it from, let's say, inside a warehouse to outside into 100-degree heat, you have to give the analyzer either enough time to adjust or you have to re-standardize. So not doing that and expecting to get the same results or quality results, it's just not going to work. The available brands that are out there, Hitachi, which recently bought Oxford, they're primarily out there because of the portability they have. They are the most portable OES. Spectro would be another. And really there's not many alternatives to Spectro and Hitachi. You may see some European instruments that are now entering the marketplace, but generally about 90% of what you're going to see out there is either Hitachi or Spectro. One new brand that is coming out, I mentioned a little earlier, a laser-based OES, is Quantilux. A couple guys that started this company a few years ago, they came from the Spark OES manufacturers, that world of manufacturing. they really designed a piece of equipment that tried to counteract all of the cons we just talked about. So given the recent advancements in lasers, they're able to create a system that's very similar in size and even smaller in most cases to Spark OES, but without almost all the maintenance issues. So there's no electrode to clean or sharpen. It doesn't always have to use argon gas, and it doesn't use as much of it. The spot size is a lot smaller. There's a lot less sample prep needed to ensure good results. So it's got a lot less maintenance and can do all the same things, sometimes better, that you see in traditional Spark OES. So keep an eye out for Quantilux. They just launched their product last year, and they look to be an alternative to Spark OES. So in review, a couple takeaways from today's discussion. Really, if you need those light elements like carbon, boron, sulfur, phosphorus, nitrogen, etc., at the low trace levels, talking hundreds of ppm or tens of ppm, you really have to use OES. It gives you that full chemistry and gives you that range that you need to determine those elements at those levels. And out in the field, there's really nothing else comparable to it. XRF and libs are not going to get you there. Second, be mindful of how much training is needed to use these analyzers. It's not point and shoot like the handheld equipment, so it really requires the technician to know what they're doing in order to get a good sample test. Otherwise, you're going to be taking multiple sample tests and the sample throughput goes way down. And lastly, as I mentioned, Spectra OES is not the only option out there anymore for OES. There is a laser OES system coming, and you should be on the lookout for it. Thanks for listening to this episode of The Manufacturing Show. Again, I'm Chris Carolan with Metal Analysis Group. Please contact me on LinkedIn to chat PMI or anything metals. I'm happy to answer any questions or provide recommendations. If you like this episode or have a question, join the discussion on Instagram at The Manufacturing Show. Thank you for tuning in and subscribing to The Manufacturing Show. Until next time, never stop testing your metal.